Trigonometry, section 1.3. This is when we introduce the trigonometric functions. First of all, we're going to have several definitions. This definition is what I call the x, y, and r definition, because we're going to take a point in the plane. It's going to have the coordinates x and y, and the distance from the origin is going to be r. So we're going to define the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant. These are the 6 trigonometric functions. They do have geometric, counterparts in a sense, relationships with geometry, but we're not going to worry about that right now. For each of these functions, there's going to be a shortcut, an abbreviation. Sine is going to look like sin, but it's still pronounced sine. Cosine is going to be cos, I guess, but I still say cosine. Tangent is tan. Cotangent is COT or cot. Secant is SEC. It'd be nice to do the COS, but we've already done that for cosine, so they use CSC for cosecant. Each of these is a function and therefore needs an argument. We're going to take an angle, call it theta. We usually use Greek letters. So you don't just say sine, you say the sine of theta, the cosine of theta, the secant and tangent and cotangent of theta. And how are we going to define these? Well, using x, y, and r. It's a relationship, and it'll make more sense maybe when we get to triangles. The sine is going to be y over r, that ratio. The cosine is going to be x over r. The tangent will be y over x, that ratio. The cotangent, x over y. The secant is going to be r over x, and the cosecant is r over y. Those are the 6 trigonometric functions, the definition being the x, y, and r definition of point in a plane. And all of these are ratios, really, of the sides of a right triangle that you can complete here. This side is of length y, and this side is of length x. So you can see that this is also this side over the hypotenuse, this side over the hypotenuse. These two sides, either y being in the numerator or x, and then r over the leg and r over the other leg. So we're going to get to those, I guess, in a bit. But since these are ratios of sides of the triangle, what's important here is we have similar triangles, and that means that it doesn't matter how big or small this triangle is. If it is similar, the ratio of this now side, call it y prime, to r prime is still going to be the same because these are similar triangles. So it doesn't matter how big or how small the triangle is. If it's a similar triangle, it'll have the same trig value, and that way we don't have to worry about the lengths of the sides. Of course, later on we'll find that's perhaps not going to help in some things. So in order to find these values, we need the point x, y, and be able to find the distance from the origin, r. But if we look at r, this distance, it's just the hypotenuse of a right triangle, which when we use the Pythagorean theorem and 0, 0 is one of the points. It's just x squared plus y squared, take the square root. So all we really need is the point in the plane. Then we can find r, and we can use that to help us find theta in different ways. Drawing a picture is going to be important almost all the time, so almost always draw a picture. It's points for your work shown anyway. The quadrantal angles, those angles that are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back around to 360 degrees. The quadrantal angles. If you want to find the values of the trig functions of those, it's sort of nice. It doesn't matter what you choose, because any point will be the point on this, any point on this positive x-axis, positive y, negative x, negative y will work. So let's choose one that is nice. Let's make the radius 1. So we know that this point on the positive x-axis is the point 1, 0. And this point is the point 0, 1. And this point is the point negative 1, 0. And this is, of course, 0, negative 1. So here's my x, y, and the r is always 1. So what is the sine of 0 degrees? It's y, 0, over r, 1, or just 0. What's the sine of 90 degrees? It's y, 1, over r, which is still 1. So it's 1. So the quadrantal angles, trig functions, are going to be combinations of 1s and 0s, and perhaps 0 in the denominator, so it's undefined. So let's write those down. Let's look at 180 degrees. What is the sine of 180 degrees? It's y, 0, over r1, or 0. The cosine of 180 degrees. It's x, negative 1, over r1, or negative 1. The tangent of 180 degrees. It's y, 0, over x, negative 1, which is 0. The cotangent of 180 degrees, don't need parentheses all the time. Mathematicians get lazy. If it's not misunderstood, you don't really need the parentheses, but your calculator is going to put it there all the time. The cotangent is x over y, or the negative 1 over 0, which is undefined. The secant of 180 degrees is r1 over x, negative 1. So it's a negative 1. And the cosecant of 180 degrees is r, which is 1, over y, which is 0, which is also undefined. So once you know a point, you can find all 6 trig functions. Let's pick another point in the plane. How about negative 2, 5? So in the plane, negative 2 and 5, someplace here. This is the negative 2 and a positive 5. We can find r, which is the square root of a negative 2 squared plus 5 squared, which is the square root of 4 plus 25, which is the square root of 29. Not a nice number, but that's okay. So x, y, and r. Sine. Now I got to call this angle something. Let's call it alpha. Do I need to know exactly what alpha is? No, I can find it now that I know the point. It is y over r, square root 29. What's the cosine of alpha? It is x negative 2 over r, square root 29. And what's the tangent of alpha? It is y 5 over x negative 2. Now, do you remember rationalizing the denominator? To rationalize the denominator, in this case, it's always going to be multiplying by that same square root. So our final answer here could be 5 times the square root of 29 over, well, this will always give you just that number underneath the radicand. So if you're asked to rationalize the denominator, that's what you need to do also. Okay, that's all there is for concepts in section 1.3, but we need to go through some examples. So, number 20. This should be around page 26, I believe, unless I'm wrong. We're supposed to find or sketch this first and then find the values of the 6 trig functions, making sure we rationalize denominators. We also need 4 steps, but this is going to be pretty easy to get. If we look at where this point is, a negative 2 times the square root of 3, so it's really closer to 4. And then a positive 2, so someplace here is our point. We've got x, we've got y. What is r? That's the square root of x squared, or negative 2 squared, plus y squared, or 2 squared. Gosh, let me start over again. The square root of a negative 2 squared to 3 squared and 2 squared. So squaring this, you square the negative 2, that's 4. Square the square root, it's 3. 3 times 4 is 12, plus 4, which is the square root of 16, which is 4. R is always positive, so you don't need to worry about the plus or minus in this case. Now these sides, this is a negative 2 squared to 3, and this is a positive 2, and this is 4. The reason I draw this picture is because it's a little easier for me sometimes with the right triangle stuff. But the sine, let's call this theta. Did they call it theta? We will. Starts here and goes there in standard position. Sine of theta is y over r, or 1/2. Cosine of theta is x over r. Well, these 2's will cancel. Tangent of theta is y over x. Well, this one's important in one sense that you don't need to get rid of the 2 and the square root of 3 or modify both this. Just the square root of 3 is all you need. So this would be 2 times the square root of 3 over 2 times 3, that's a negative. These will cancel, so this is really just a negative square root of 3 over 3. The cotangent. Sometimes it's easier to start noticing that some of these are ratios of others. They're all ratios of others. The cotangent is just the reciprocal. So instead of 2 over negative 2 square roots of 3, this will be negative 2 square roots of 3 over 2, or x over y. Well, the 2's cancel, you get the negative square root of 3. So I guess we should be circling these, right? The secant is r over x, 4 over negative 2 square roots of 3, goes once here and twice. So it gets to be negative 2 over the square root of 3. Multiply both by the square root of 3. You get negative 2 square roots of 3 over 3. and the cosecant is r4 over y, 2, or just 2. So this is more than you need for 4 steps, right? Let's do number 36 on the same page. It'll fit. Suppose the point xy is located in the indicated quadrant. Decide whether the ratio is positive or negative. For 36, they're saying it's in quadrant 3, and the ratio is x over y. So to show some steps, quadrant 3, any point x and y would have to be in negatives, right? Both x and y are negative. So even though they don't list it here as negative and negative, those values have to be both negative, but they cancel. So we know that it's going to be positive. Number 56. They say an equation. The terminal side of an angle, standard position, is given. Sketch the positive such angle. Find the values of the 6 trig functions. For 56, they say y equals 0, x less than or equal to 0. So y equals 0 is really a line through the x-axis. So that's an angle of 0 degrees. That's a quadrantal angle. We can use a point on there, just 1, 0, and the radius is 1, just because we can choose anything we want on that side. So the sine of this theta, 0 degrees, y over r, 0 over 1, the cosine, x over r, 1 over 1, the tangent, y over x, 0 over 1, the cotangent is x over y, 1 over 0, the secant is r1 over the x1, or 1, and the cosecant is r, which is 1 over y, which is 0, undefined. So, got all those steps too. So once again, we're supposed to use our knowledge, I guess, of these quadrantal angles. And I guess what helps me is if I always draw this picture. I got the 1, 0. In fact, I usually draw a circle here. This is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. And from that, realizing that r is always 1, then I've got the sines and cosines, the x's and the y's, and it's all going to work. So, negative 180 degrees is this point right here, with r equal to 1, of course. So, the cosine of a negative 180 degrees is x negative 1 over r 1, which is negative 1. Cosine squared of a negative 180 degrees is just the cosine of a negative 180 degrees squared. They put the square next to the cosine so you don't square the 180. Negative 1 squared is positive 1. The sine of a negative 180 degrees, well, the sine is the y, 0 over r, 1, or 0. And the sine squared of a negative 180 degrees then would be 0 squared, or 0. So cosine squared is 1 plus sine squared 0, which equals 1. Number 92. for our last one in this section, number 102. We're given this cosecant of n times 180 degrees. Now the directions. If n is an integer, then n times 180 degrees represents an integer multiple of 180 degrees. 2n plus 1 times 90 represents an odd integer, and so on. So whether the expression is equal to 0, 1, or negative 1, or is undefined. So let's see here. If you'd say it's the cosecant of 180 degrees. Well, let's see. That's back up here, right? 180, negative 180, same thing. You're going to be here. So the cosecant is r, which is 1, over y, which is 0, which is undefined. And if we use a positive one, we'll get that. A negative one gives us a negative 180, which is the same thing. Suppose I wanted 2 times 180 with a cosecant of 360. So 360 is back here. And the cosecant is r1 over y0, which is still undefined. And what you'll find is if you keep on going, that's what's going to happen all the time. It'll be one of those 2 points, either the 0 or the 180, and you'll always get undefined. Because of the division by 0. Okay, section 1.3 is finished. Should be able to do the problems in the exercise set for that.